When you think about building really great software, it's tempting to picture this giant, perfect blueprint, right? Everything planned out from day one. But what if that's not how the best designs happen at all? What if they just kind of grow?
And that really gets to the heart of it, a question every single one of us is asked at some point. How do those, truly elegant, clean, maintainable designs actually get built?
Well, the answer, at least according to Clean Code, is pretty surprising. They aren't planned out in painstaking detail. They emerge. It's this idea of emergent design, where a great design can just sort of happen organically, as long as we're following a few key, simple rules.
All right, so here's the game plan. We'll touch on what emergent design actually is. Then we'll tear through Kent Beck's 4 rules in order of priority, running all your tests, squashing duplication, being super expressive in your code, and finally, keeping things minimal. And then we'll wrap it up by looking at how this all becomes a continuous craft.
So yeah, the big goal here is to get a design that feels like it was planned and is super clean. But, and this is the key part, without getting stuck in analysis paralysis, trying to figure it all out up front. We're hunting for a set of practices that let a good design just bubble up to the surface while we're actually coding.
And the book frames it with this perfect question. The whole idea is that this isn't some kind of magic or mystical process, right? It's actually a really practical, disciplined approach. And these 4 rules, which come from the legendary Kent Beck, they're the roadmap to making it happen.
Which brings us to rule number 1. And you got to hear me on this. This is the absolute foundation. It's the highest priority. Your system must run all the tests. Period. It is completely non-negotiable.
Look, before your design can be elegant or beautiful, it has to be one thing: correct. And the only way you can really prove that your system does what you think it does is with a solid suite of tests that passes every single time. Honestly, a system you can't verify, it probably shouldn't even see the light of day.
Okay, but here's the really cool part. This is where the magic happens. Just the act of writing tests forces your design to get better. Why? Because to make your code testable, you're almost forced to create smaller classes that do just one thing. The single responsibility principle, SRP. You also have to break up your dependencies, which naturally leads you to things like the dependency inversion principle, or DIP. So get this. Just by writing tests, your design improves almost automatically.
And that's what this quote is all about. Those tests, they become your safety net. They completely eliminate that fear of, oh man, if I touch this, I'm going to break something. With that safety net, you have the confidence to go in and clean things up, to refactor, to make your code better all the time.
Okay, so once that safety net is firmly in place, now we can move on to the next big priority, hunting down and destroying duplication.
And the book is so blunt about this, I love it. Duplication isn't just a minor annoyance, it's the primary enemy of a good design. Think about it. Every single time you copy and paste code, you're creating a future headache. A change in one place now means a change in 2, or 3, or 10 places. It's more work and way more risk of messing something up.
Let's look at a classic example right out of the book. Imagine you have 2 methods for calculating vacation time, one for your US division and one for the EU. The guts of the calculation, the core logic, it's exactly the same. The only tiny difference is how they handle the legal minimums. That right there is a textbook case of duplication.
So what's the fix? Well, a fantastic tool for exactly this kind of problem is a design pattern called the template method. The idea is simple. You create a base class that outlines the main skeleton of the algorithm, the parts that are the same. Then you let subclasses fill in the specific details that change.
And voila! Check out the result. Now we have a single, abstract vacation policy class that takes care of all that common code. The little bits of specific logic for the US and EU, they're tucked away neatly in their own subclasses. The duplication is just gone, and the whole thing is so much cleaner and way easier to deal with.
All right, rule 3. We've got our tests, we've cleaned up the duplication, now our focus shifts to something a little more human. Clarity, communication. We have to make sure our code is expressive.
And B's 2 quotes just nail it. Grady Booch says clean code should read like well-written prose. Simple, direct, easy to follow. And then Ward Cunningham chimes in, saying that when you read clean code, it should be exactly what you expected. No shocking twists, no surprises. It just makes sense.
So how do you actually do that? Well, it starts with the simple stuff, picking good names for things, names that actually tell you what they do. It means keeping your functions and classes small and focused. It helps to use standard names for things, like when you use a design pattern, call it by its name. Even your unit tests can be a form of documentation, if they're written clearly. But you know what the book says is most important? You just have to try. You have to actually care about the code you write. Take some pride in it.
And if you need one selfish reason to do this, here it is. The person most likely to have to read your code 6 months from now is you. We think we're writing code for our teammates, but really, when you come back to fix a bug or add a feature, you're going to have to decipher what you wrote. Clear, expressive code is basically a gift you give to your future self.
Okay, last but not least, and I say least for a reason, we're at rule number 4. And notice this is the lowest priority rule. Minimize the number of classes and methods.
So this rule is all about finding a balance. Rules 2 and 3 are pushing us to make everything small, right? Small classes, small functions. But if we go too crazy with that, we could end up with a system that has thousands of tiny little pieces, which is a whole other kind of complexity.
Yeah, this rule exists purely as a sanity check, because you can absolutely take the other rules too far, especially the one about making things small.
And that's the real point here. This rule is a guard against what the book calls pointless dogmatism. You know those rigid team rules like every class must have an interface, no exceptions. Sometimes that just adds noise. This last rule is all about being pragmatic. It's a reminder that yes, the other rules are crucial, but the ultimate goal is a simple, working system, not just ticking off boxes on a checklist.
So, let's pull this all together. What's the big picture? It's that these 4 rules, they aren't just a checklist you run through and then forget. They're meant to be a complete mindset, a holistic way of approaching how you build software. Because at the end of the day, simple design isn't some destination you arrive at and then plant a flag. It's a craft. It's a continuous process of refinement. Every day, you're applying these rules, making sure the tests pass, refactoring to kill duplication, tweaking names to make them clearer, and just generally keeping an eye on complexity. That is the craft of building clean, elegant software. So the real question to leave you with is, are you practicing that craft every single day?